Hey guys, we are going to start with motion, right? Motion in one dimension, motion in two dimensions, motion in three dimensions. Let us see what is this motion in one dimension. Okay, before motion in one dimension, I would consolidate one point here. Whenever we consider objects here in physics, we say that the objects are point objects. Now, what is a point object? Every object cannot be a point object, because when I take this marker again, it's this is one example which I'll be giving you quite often. Always, whenever I think of something, I'll start with this marker. Okay. Now, this marker, if you see the shape of this marker, it has got some length. Compared to its length, its diameter is very small. Great. But still, I'll be treating this marker as a point object. Now, what is the logic in that? Some time back I read one numerical problem where it said a particle of mass 1000 kg is moving with certain velocity. Now, a particle of mass 1000 kg, if I tell this to some other friend of mine who is not really doing science or physics, he would say you have got insane. Okay, are you in your senses? You're saying a particle of mass 1000 kg. If you say a particle, it should have negligible mass. So I agree with that. Now, what are the dimensions of a point? When you say point, it has got very, 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 and very small dimension. If I talk about a line, okay, what is a line? Line is a collection of points in one direction, correct? And what is the thickness of a line? Thickness of a line, again, it is negligible, correct? So a particle has got negligible dimensions, a line has got negligible thickness. Then why do I consider all my bodies as point masses? Now now the explanation over here is something like this explanation you might find in many books on physics. When we say, when the change in position of an object is, it is far, far greater than uh, its own size. Okay, for example, this has got a diameter of, let us say, 13.5 millimeter, and if it is moving from here to there, okay, I would say that its change in its position is much more than its own size, its own diameter. So I would consider that object as a point object. Okay, but then there would be, you might think that there are some assumptions in this, and no one likes assumptions. But then in physics, we do assume things, and then based on the assumptions, we derive certain results, and then after we get the results, then we compare the results with the reality. Okay, and then we verify the results. If the results are verified, fine. Okay, but then I'm going to give you an example which you can relate. Okay, now there is, when I was in my junior college, I used to travel to my college by train. Okay, and there was one station here. Okay, one railway station here. Okay, and the next railway station was somewhere here. And the days, when I used to go to my junior college and used to travel by train, uh, the local trains in Mumbai, they used to have 9 compartments, 9 coach rakes were there. Okay, and this is one station. We'll call this D, and the other station, next station, was S. Now, the funny thing about these two stations is that they were very close to each other. Okay, now let us have my train here. My train is standing in this station. Okay, now what? Now train leaves from here and starts moving towards the next station, station S. Okay, and while it is moving in this direction, what used to happen? My front part. Okay, I'll just take them little more closer here, because my train. I cannot change the size of my train now. Alright, uh, this train, as it traveled from D to S, at some point of time, the stations were so close that it used to be like this. The motorman of the train used to be in station S, and the guard of the same train still used to be in the previous station D. Okay, and then then again it used to move further, and finally the train used to land here. Okay, now in this condition, what would you say? The station has left the station D, the train has left the station D, or can you say that train has reached station S? I cannot say, because my motorman is already there in station S, but my guard is still in station D. So how do I solve this problem? So you know what I'll do? I'll mark the midpoint of station D over here, and midpoint of station is here, and then I'll have the midpoint of train. Okay, now I do one convenient thing. The moment the midpoint of train crosses the midpoint of station D, I will say that the train has left station D. Okay, and the moment this midpoint of train coincides with midpoint of station S, then I will say that the train has reached the next station. Okay, until that time I wouldn't say that it has reached the station, because the motorman may cross this point, but then as long as the center of the train does not coincide with center of this station, I will not say that it has reached. Correct. So that is the concept of a point object, and that is the logic behind considering all the objects as point objects. Correct. So this is something you might not find in many physics textbooks, but then this was one way of relating this concept of point objects. In the next video we are actually going to start with motion in one dimension. Thank you.